All right, I realize the Zoom meetings are optional, but if you guys keep sending me emails that you don't understand what's going on, you need to join me on Mondays and Wednesdays at 11 a.m. Okay, and it's on the checklist. It tells you the ID and also the password to get in. All right, it's good to see you, honestly. All right, so we did similar triangles. We did similar polygons. Now we're going to do similar solids or three-dimensional shapes, okay? You know what similar means, okay? Write this in there. Similar solids are going to have the same shape, but not the same size, okay? Then the ratio of their parts are going to simplify and be equal, all right? So two solids are similar if the ratio of their corresponding linear measurements, that's their parts, are equal, all right? This is very, very, very simple. This is lesson 25.4. I know I made 25 geometry videos. How exciting is that? And we're just going to see, are solids similar? Okay, directions. Determine whether the solids below are similar. If yes, give the scale factor. Okay, all you're going to do is line up their corresponding parts. So look, the height of this pyramid is 12 over here. So I'm going to put 12. And then I'm going to match it up with the height of the smaller one over here. I'm going to put 3. If you put the measurements from this shape on the top, you got to keep that consistent pattern, okay? So you got to put all the larger measurements from the larger pyramid on the top and the smaller one on the bottom. All right, let's go to the next measurement. See this 8 right here? All right, I'm going to put it here, and it corresponds with this 2. And then finally, I'm going to grab this 20, all right, and it matches up with the 5. You guys have done this before. You didn't like it, but now we're going to take those matching parts, those linear measurements, and see if it's the same ratio. When you divide or simplify, look, 4. Divide 4. When you divide 4, okay, so you're saying the larger one, all right, dimensions are 4 times bigger. Okay, their linear measurements are 4 times bigger. So the answer is going to be yes. Okay, this is the first thing you got to do. If they give you 2 solids, you're going to tell me whether or not those babies are similar. Super, super easy. Okay, this next segment is going to bug you at first, and then you just got to breathe, okay? This is actually very, very useful too. This is I like this one, okay? So go down to the towards the bottom of the worksheet, and we're going to talk about if you do know the solids are similar, all right, how that's going to affect volumes and how that's going to affect, surface area. Okay, so let me try to say this in English. If you know the scale factor, like in that last example where we got 4, all right, where the one shape was 4 times bigger than the other, you would say the scale factor is 4 to 1, okay? So this A to B means whatever scale factor you come up with, all right? So it's A to B. In that example, it was 4 to 1. All right, if you want to find out the ratio of the surface areas, you're just going to take A and square it. You're going to take B and square it, and that'll be the ratio of the area, the surface areas. If you want the ratio of the volumes, then you will take the original A and you'll cube it, and you'll take the original B and cube it. And remember, square is A times A, B squared is B times B, whereas A cubed is A times A times A, and B cubed is B times B times B. Okay? Are you with me so far? Okay? All right, hold on. I'm telling you, when I do a real example, it's going to completely make sense. All right, so let's take a look at number 4. I'm going to bring that baby into focus for you. All right, I spend most of my day, I swear, just trying to get these worksheets in the right spot so you all can see them. All right, it says identify the scale factor ratios for the pair of solids that you see right here. Okay, so I'm just going to make my life easy. I'm going to go with this height right here. See this height? I'm going to go 6 is the height, all right, of this prism, all right. Well, actually, it's the height of that triangle. My bad. I'm going to match it up with the height of the triangle over there. And if I go like this, all right, it's going to reduce to 2 to 1. All right, if you don't believe me, look, 14 divided by 7 is 2. 10 divided by 5 is 2. We're saying the linear measurements over here are twice the length of the ones over there. So for scale factor, you're going to write 2 to 1. Okay? Just take that fraction, 2 to 1, write 2 to 1. All right, the surface area, the formula says to square both. So you're going to go 2 to the second power versus 1 to the second power. So your next answer, this is for the previous one here, all right, when you square both of that, the surface area is going to be a 4 to 1 ratio. I know, you're sitting there thinking, wow, that's the most exciting thing ever, all right? So if your shapes are similar, your three-dimensional shapes are similar, and the dimensions of one is twice the dimensions of the other, it'll make the volume of the larger 4 times bigger than the other one. That's what it's trying to say in English. And then finally, for the volume ratio, you take the original 2 to 1, you go 2 to the third power versus 1 to the third power, all right? Whatever you do, please don't yell out 6. I know you want to yell out 6, but it's 2 times 2 times 2. And so this is going to be an 8 to 1 ratio. That's for the volume. Okay? So folks, it is this simple. All right? You are literally going to match up, all right, parts of the two shapes. You're going to reduce, reduce, reduce. And then once you get that original ratio of the parts, if it's 2 to 1, then the ratio of the surface areas will be 2 squared over 1 squared, simplified at 4 over 1, and then the volumes will be 2 cubed to 1 cubed, which is 8 to 1. Okay? And real quick, I'll just slide it over, the notes over there on the top, so you can see. Actually, I can just slide it over and put those babies in the right spot. Ooh, I like that. All right, I slid it over. You can't see the original problem, but at least you can see those answers are in there, and you can see, look, if it's originally A to B, area, A squared to B squared, volume, A cubed to B cubed. If you're finding this to be easy, that is what I want to hear. I love when I hear easy, easy, easy. Once again, it's good to see you, and I hope to see you in person soon.